significant figures. This lesson is a review of significant figures and why we need to use them. Significant figures indicate the precision of a measurement. The more significant figures, the more precise the data. Precision is not the same as accuracy. A precise measurement is one made with a precise measuring instrument. The more decimal places in the measurement, the more precise. Precision is also an indication of how repeatable a measurement is. If you get the same, or very close to the same number over several measurements, that measurement is more precise. Accuracy is an indication of how close to the real answer a measurement is. Measurements taken with a precise scale that is off by 5 grams are not accurate. Instruments are calibrated to make them more accurate. The goal, of course, is to be both accurate and precise. When recording data and doing calculations, the number of significant figures indicates how precise a measurement is. This is Siegfried Fig. He is going to guide us through the rules for significant figures. The first rule is that all non-zero digits are significant. This is easy enough. In any measurement, count all the digits 1 through 9 as significant. But what about zeros? The rest of the rules deal with zeros. The second rule is that any zeros surrounded by non-zero digits are significant. This is sometimes called the sandwich rule. The third rule is that zeros at the beginning, to the left of a number, are not significant. They are just there to mark the decimal place. The first part of Rule 4 is that zeros at the end of a number, to the right, are significant only if there is a decimal point in the number. The second part of Rule 4 is that zeros at the end of a number are not significant if there is no decimal point in the number. There are exceptions to this, and it is best determined by context. If the number is obviously an estimate, say there were 1,000 people at the demonstration, those zeros are not significant. But if it is clear that the number is exact, a zero at the end may be significant. There are 10 people in the room. That would be 2 significant figures. The easiest way to clarify zeros at the end of a number is to use scientific notation. In scientific notation, all the numbers in the coefficient are significant. The 10 and the exponent are not significant. To use significant figures in calculations, there are rules depending on the type of calculation being done. If several measurements have been made and a final result is some combination of those measurements, it is necessary to determine the number of significant figures in the final answer after the measurements have been combined. There are separate rules for addition and subtraction calculations and for multiplication and division calculations. For calculations involving either addition or subtraction, there can be no more digits after the decimal point in the final answer than the least number of digits after the decimal point in the initial numbers in the calculation. The final answer cannot be any more precise than the least precise measurement. For multiplication and division, the final answer cannot have any more significant figures than the number with the least number of significant figures of those being multiplied or divided. The exceptions to these significant figure rules are exact numbers. Exact numbers are those things which are countable. 3 people, 2 buses. Also, specific defined conversion factors are exact numbers. So that if you're converting from meters to centimeters, that is an exact number. Exact numbers can be assumed to have infinite significant figures. They do not affect the number of significant figures in the final answer.